Hello friends, welcome to Kranti Physics Tutorials. Okay, so today we have to discuss about the energy. So, and the types of energies, kinetic energy and potential energy. So, energy, kinetic energy, potential energy is under the topic, you have under the topic work, energy, power. Okay, so what is the energy? So, energy means capacity to do work, capacity to do work. So how much capacity a person has to do work, so that capacity is called as the energy, right? So we have two types, generally we have two types of energies. So first one is the kinetic energy and the second one is the potential energy. So kinetic energy. So what is the kinetic energy? First of all, we will discuss about the kinetic energy. The energy possessed by the body by virtue of its motion or its velocity is called as the kinetic energy. The energy possessed by the body by virtue of its motion or velocity is called as the kinetic energy. So if any body, so it gains some energy due to its motion or due to its velocity, so then that energy is called as the kinetic energy. So for example, we can take a bullet using in the gun. If you can fire the bullet, so using inside the gun, so then it will be so very damaging to that person. So the same bullet, if we can throw through our hand on that person, so there is no lot of energy gained by that body, so there is no damage to that person. But the same bullet is inserted into the gun, inserted into the cartridge, and so we can fire that gun, so the bullet so penetrate into the flesh of the man. So why, how the bullet so gain that much of energy to penetrate to that person? So that is because of it gains some energy due to its velocity, due to its motion. So that energy is called as the kinetic energy. So that means, so if any body in the universe, it gains some energy, it possessed some energy, so due to its motion or due to its increasing velocity, so then that energy is called as the kinetic energy. So now what is the kinetic energy equation? So kinetic energy is equal to half mv square. So this is the equation for kinetic energy. So kinetic energy equal to half mv square. Here m represents the mass of that body, v represents the velocity of that body. So half into mv square is the equation for kinetic energy. Now how we get this kinetic energy? Now we will derive here. Okay, so for example, if we consider a body is initially moving with some velocity v. For example, if we can consider a body is initially moving with some velocity v, so then if we can try to stop that body, so then using how we can try to stop that body? So we can apply some force against the motion of that body. So here we can apply some force F onto the body. Why? Because so we need to stop that body. So then what happened? So at a certain distance, so at certain distance s, so the body will be stopped. Now we have to derive the equation for kinetic energy, that is half equal to mv square, using this example. So now we have the kinematic equation, that is v square minus u square equal to 2as. So now here v is 0, final velocity is 0. Why? Because finally the body will be stopped. So but the initial velocity we considered as v. Why? Because it is already moving with some initial velocity v. So then here we can substitute u equal to v and v equal to 0, and so the displacement is s. So in place of we can substitute 0. So 0 square minus u equal to v square is equal to 2as. So from this, so what we can write? So a equal to minus v square by 2s here. So here that means a is here the retardation of the body. Why? Because the velocity of the body is gradually decreases. So if we can apply the force against the motion of that body, so that retardation a is equal to minus v square by 2s. So retardation is the opposite of the acceleration. That's why here we can get minus sign. Okay, we can substitute this retardation value in f equal to ma. So then what we get? So f equal to, so m minus m v square by 2s. So this is the applied force on the body. So f equal to minus mv square by 2s is the applied force on the body. So now the force by the body according to the Newton's third law. So if you can apply the force on the body against the motion of the body, so at the same time the body is also, so apply the, so reaction force, so on the applied force. So that's why the force by the body, so the force by the body, so f equal to, so minus of minus mv square by 2s. So why? Because so this is the reaction force. So reaction force we can take negative sign, so minus, and actual force, applied force is minus mv square by 2s. So here we can substitute minus mv square by 2s. So minus into minus, so we can get plus. So f equal to mv square by 2s. So this is the second equation. So this is the force applied by the body. Okay, so now, so here some force is applied on the body and the body is displaced some distance s. So force is there and displacement is there. Some work is done here in this case. So that's why, so work done. So work done in this case, is so W equal to, so F dot S, work done. So F means force, S means displacement. For S cos 0, we can remove the dot product, we get cos theta here. So here the force by the body and the displacement both are in same direction. That's why the angle between them is 0. So that 0 is substituted in this cos theta. So then cos 0 means 1. So then finally, so what we get? Fs. So in place of F dot S, finally what we get? Fs. So now what is the F from equation 2? So equation number 2, so mv square by 2s. So how much will mv square by 2s? So into yes. So ss cancel. So finally, so half mv square. So W, how much work is done here? So half mv square. So this work done is stored as a kinetic energy, so in that body. So that's why, so we can substitute here. So this work done is stored as a kinetic energy in the body. So that's why in place of W we can write K, kinetic energy. So K equal to, so half mv square. So this is the kinetic energy equation. So this is about kinetic energy. Now we will discuss about the potential energy, right? Generally potential energy is denoted by the letter U. Okay, so potential. So what is the potential energy? The energy possessed by the body by virtue of its position or state or arrangement is called as the potential energy of that body. So the energy, so if any body is, if it is gains some energy, so due to its state or due to its position, so then, or due to its arrangement, so then that energy is called as the potential energy of the body. So for example, so if a body is placed so on the surface of the another body, then there will be no potential energy in this body. But if we can so move this body up to some height, so then this body at this position, this body has some potential energy. So why? Because so why this body, this body has gains some energy at this position due to its state, due to its height. So we can doing some work to move this body from this place to this place. So how much work is done so to move this body from to this much of height, so that work done is stored as a potential energy in this body at this position. The another example is, so if the in a reservoir, if the flowing river water so can be stored in the reservoir, so using, so we can place the dam. So that's why they gain some energy, potential energy. So the another best example is, so the water stored in the so tank at the top of our building. So generally, so in any building, so the water, the syntax or the water tank is placed at the top of the building. So why? Because so whenever we can store that water to that much of height, wherever we can so open our taps, the water will be flowing through the taps without using the external energy. So why? Because so already the water gains some potential energy. So why? Because due to its height, we can store the water at so lot of height. So that's why the water has potential energy. So that's why just we can open the taps at anywhere in our house, then the water will be flowing through that water without using any current motor. These are the so best examples for the potential energy. So finally what we can say that, so due to its position, due to its state or due to its arrangement, so some bodies are gains some energy, so that energy is called as the potential energy. So now we can derive the equation for potential energy. So you can see, so for example, so we can consider a body of mass m, so it is placed on the surface. So then so we can move this body so up to some certain height h, so using some force. Then so the bodies, so here force is how much? So here force equal to mg. So why? Because the total weight of the body, so weight of the body is how much? Mg. So the total weight of the body is applied in the downward direction. So if you can move this much weight of the body to up to this height, then we can use the same force, that force is equal to its weight. So that's why here F equal to mg. So F force, mg force we can apply on this body, and we can lift this body to up to this much of height h. So here so some force is applied and some displacement is also there, work is done here. So that's why how much work is done here? So work done equal to so force dot displacement. So force dot displacement, if we can remove the dot product, then we get cos theta term. So here the force applied and the displacement is also in the same direction. That's why the angle between the force and displacement is 0 degrees. So then we can substitute, so Fs cos 0 degrees. So cos 0 is 1. So that's why finally what we get? Fs. So here how much force is applied here? So mg force. That force is equal to the weight of the body mg. And what is the displacement here? So displacement s equal to h, height here. So that's why so we in place of s we can write h. So w. So here how much work is done? So w equal to mgs. So this much of work done is stored as a, so this work done is stored as a potential energy in that body at this height. So that's why we can write, so U equal to, in place of W we can write U, and U equal to, so mgh. So finally, what is the equation for potential energy? mgh. So in previous, what is what we have got for the equation for kinetic energy? Half mv square. So half mv square is the equation for kinetic energy, and mgh is the equation for potential energy. Then now, what is the total energy? So total energy is equal to, so kinetic energy plus potential energy. So now here, so we will look about the units of energy. So kinetic energy or potential energy are merely called energy. So what are kinetic energy, potential, both are the energies. So that's why, so the energy, so here energy has units and dimensions same like as work. So the work and energy, so both are has the same units and same dimension formula here. So what are the units for energy? So joule. So the work and energy has, so same units and same dimensional formula. So here, what is the dimensional formula? So dimensional formula for the energy is, so ml square T minus 2. So the SI units for energies are energy and work, so are same. The SI units are, what are the SI units? So joules. And what are the dimensional formula? ml square T minus 2. And what are the CGS units? So CGS units equal to ergs. CGS units equal to ergs. So 1 erg equal to 10 to the power of minus 7 joules, already we discussed. So here we also have some alternative units. So alternative units. So what are the alternative units? So electron volts and calorie and so kilowatt hour. We have three alternative units for energy. So electron volt, calorie and kilowatt hour. So electron volt unit is used for energy in the atomic structure, and calorie is so used for the energy for a human body. Kilowatt is used in a power consumption. Generally the electricity, the power consumed in our houses, in our domestic purpose or commercial purpose, so we can use current. So that consumption of the current so will be expressed in terms of kilowatt hour. So here we have finally three alternative units. 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules. So here 1.6 into 10 to the power of minus 19 is the charge for electron. Already we know that value. So that much of 1 electron volt is equal to that much value, 1.6 into 10 to the power of minus 19 joules. And 1 calorie is equal to 4.186 joules. Okay, next. And finally 1 kilowatt hour is equal to 3.6 into 10 to the power of minus 6 joules. Okay, so finally you must and should remember, so the work and the energy both are having the same units and the same dimensional formula. So those are joules, okay, SI units, and CGS units are ergs. But additionally the energy also has three alternative units. So those are those are called electron volts and calorie and kilowatt hour. So all these three units we can use in different purposes. Okay, so this is about energy, right? Everybody, is it clear? So thank you. So this is Kranti, so signing off.